I want to go back to similar figures today. Similar figures. Ratios of corresponding sides are in the same corresponding sides are in the same ratio. So here's what I need you to do for me first. You have graph paper on the next page. I don't know if some of you guys want to open up your packet. All right, so you're not flipping it back and forth, or it looks like you guys will have to flip back and forth. Sorry. Can you do me a favor? On that graph paper right now, can you draw me a 3x4 rectangle? All right, a 3x4 rectangle. And in a second, I'm going to ask somebody for the perimeter of that 3x4 rectangle and the area of that 3x4 rectangle. Okay, so go ahead, graph yourself a 3x4 rectangle, find the perimeter and find the area for me. Okay, perimeter and area of that 3x4 rectangle. Perimeter and area for me. What are you guys looking at? Ever since they did the little update on... Okay, what are we looking at? I'm going to go 17. What are we looking at? The 3x4 rectangle. So in the chart right here. Oh, will you? 14 units and? Yep, 12 square units for the area. Good. Here's what I need your help in now. Can you create 3 rectangles that are similar to the 3x4? And remember, when I say similar, their corresponding sides have to be in the same ratio. So what would be another dimensions I could have for a rectangle that's similar to a 3x4? So their corresponding sides are in the same ratio. 6 by, okay, that's what usually happens first. So everyone go ahead. 6 by 8. And if you don't feel like graphing it, I'm not going to force you to graph it if you can already figure out what the perimeter and the area is. Oh, look at that. 7, what do you got? Okay. Guys probably aren't noticing any pattern yet, and I don't expect you to. Anybody want to give me another similar rectangle to the 3x4, Madeline? Okay, so we're dividing both of them by 2, so 1.5 by 2. Yep, that's good. That's a similar rectangle to the 3x4. So go ahead, everyone, find the perimeter and area of a 1.5 by 2 rectangle. When you're ready, 3. Oh, look at that. All on the absent. 15, how about that? Good so far. Anybody want to give me a third and final rectangle that's going to be similar? Jack? 9 by 12, just multiplying by 3, fine. $21 when you're ready. What is it? Yeah. Everyone agrees all 4 rectangles are similar. Okay, now we're going to start comparing their perimeters and areas in the chart below. A quick review, similarity ratio. Quick review, similarity ratio, that's the ratio between 2 corresponding sides. We've used that term before, but just a little reminder, ratio between 2 corresponding sides. Take a look at rectangle 1 to the original. Give me a pair of corresponding sides and their ratio right now. Rectangle 1 to the original. Give me a pair of corresponding sides and their ratio. Here you go, 17. You go, Enrico? Okay, I want to go 1 to the original, though, so 6 to 3. Reduces down to what? 2 to 1. So the similarity ratio for rectangle 1 to the original was 2 to 1. Now let's compare their perimeters. Their perimeters were 28 and 14. Ho-ho! Reduces down to what? 2 to 1. Okay. So the ratio of their perimeters is also 2 to 1. What about their areas? Not 2 to 1. 48 to 12 would be 4 to 1 when it reduces down. 4 to 1. Oh. Here comes some of your math abilities. There it is. All right, there it is. Garbage. Too rough, honors kids. Can't handle it. Let's go to 2 in the original now. 2 in the original. What's my similarity ratio now? 1.5 to 3, 2 to 4. Similarity ratio now, 26. 1 to 2. Go ahead, compare their perimeters, 7 to 14. Also, 1 to 2. Hopefully you're starting to notice something between the similarity and the perimeters. And what about their areas? 3 to 12. 3 to 12. 3 to 12. 1 to 4. Yes, Jack. I'm not there yet. Calm down. I still have one more to do. 3 to the original. Give me the similarity ratio. 3 to the original would be what similarity ratio? Let's roll 7. 3 to 1. Perimeter ratio, 42 to 14. Also, 3 to 1. And what about 108 to 12? 9 to 1. All right, let's start talking patterns now. All right, let's start talking patterns. You know the similarity ratio of two similar figures. You also know the ratio of their perimeters. All right, that's the theorem that's going to go down. All right, next page, there's a theorem. You're going to write 2 of them down. So we're going to start this with if two figures are similar. God, noise. And just so you know my notation here, guess what S1 over S2 represents? That's my similarity ratio. That's the similarity ratio. Whatever that ratio was or is, it's the same as what ratio? What did we just find out? 11? It's the same as the? So I'm going to put P1 over P2. Those ratios are always the same. Whatever the ratio between the sides are, that's the ratio between your perimeters. And if you need to jot that down, that P for perimeter. All right, that's the ratio of the perimeters. Okay, was this true? That your similarity ratio and the area ratio were the same. Was that true? Is that a true statement? No. Look back at your chart. That's not true. Can somebody fix it, though? What must you do to your similarity to get to your area? Okay, Jack, go ahead. Square what? I got a couple things I could square up here. Square your similarity ratio, and you'll have your area ratio. Okay? That's the relationship. Everything. Only if the figures are similar. Okay? The ratio of the perimeters and the similarity ratio will be the same. Square the similarity ratio, you'll get the ratio of the areas. All right, let's go. 1 and 2, those figures are both similar. Find me the ratio of the perimeters and the ratio of their areas. Before we start anything, what's the similarity ratio? What is the ratio of two corresponding sides in number 1? I didn't make it too difficult on you guys. 21, what's the similarity ratio up there of those two figures? 4 to 5, which means what about your perimeters? The ratio is also 4 to 5. Now, I got to make this clear. Am I saying that the perimeter of one is 4 and the perimeter of the other is 5? No, I'm saying whatever the perimeters are, you put them on top of each other, they'll reduce down to 4 to 5. All right, don't think that the perimeter of one is 4 and the perimeter of the other is 5. That is not true. But the perimeters are in some ratio of 4 to 5. All right, what about the areas? If I calculated the areas of those two similar figures, their ratio would be not 4 to 5, but what do I do? Go back, look up top. It would be, yep. 22. How'd you get it? 4 squared, 5 squared. Am I saying the ratio is, the areas are 16 and 25? No, I am not. I'm saying that whatever they are, they'll reduce down to 16 and 25. That's what I'm saying with their ratios. Okay, 2, slightly trickier. You know they're similar, but what the heck does that 3 match up with? Okay, what would that 3 match up with for your similarity ratio? Try to match the congruent angles on top of each other. What would that 3 have to match up with? Because that'll be my similarity ratio. Hey, 25, what's the 3 match up with? 3 matches up with the 5. Everyone in agreement? So that must mean my similarity ratio is 3 to 5, meaning the perimeter ratio is also 3 to 5. And how about the area ratios? Whatever they happen to be, the areas will reduce down to what ratio? 2? How'd you get it? So it's going to be 9 over 25. Again, guys, please do not confuse this. That's not the areas of both. That's just the ratio that they're in. Any issues finding it before I go backwards? All right. 2 regular hexagons. Area of one is 8. Area of the other is 32. What must have been the similarity ratio? So I'm giving you the areas. The areas are in a ratio of 8 to 32. If you feel like reducing, go ahead. So think, how would I go backwards now? Now I'm given the area and I need to go backwards. What should I be doing with my ratio now to get to the similarity ratio? Any thoughts of going backwards here? 3? Nope. Hey, how about 26, going backwards? How do I go from similarity to area? What have I been doing? Go backwards? Square root both. Okay, I can take the square root of both. So square root of 8, square root of, reduced it. You take the square root of 1 and 4. That should come out to be a nice clean fraction, which I'm not going to do for you. That's why we have fraction templates and radical symbols. What do you got for me? 7, similarity ratio? 1/2, yep. All good? Okay. 2 circles now. Area of one, 128 pi. Area of the other, 18 pi. You could keep it in there, but what's going to cancel each other out here? The pies can go. So the ratio of their areas is 128 to 18. So just like we did in the previous problem, I can take the square root to find the similarity ratio. $24 when you're ready there. Change it back to a fraction. I want to sloppy decimals. 3/8. Yep. That's correct. No issues with that. I got a question though, kids. I told you guys, you guys have known all year, similarity ratio, ratio of two corresponding sides, right? But this is a circle. Circles don't have sides. So what is this comparing that's in a ratio of 3/8 if you don't have sides in a circle? What else can you measure in a circle? Diameter or radius, okay? So even though a circle doesn't have sides, this is saying the radii or the diameters in this circle, these two circles are in a ratio of 3/8. That's my catch anyway. Questions? Yes, Skylar. Well, it's whatever you can measure in a circle. Well, you wouldn't have to pick anything here, but you could say the radii are in a ratio of 8:3. The diameters are in a ratio of 8:3. Okay, it's not looking for anything specific here. Okay. All right, now here's where we're going to apply this. Shorter side of a rectangle, 6 feet. Shorter side of a similar rectangle, 9 feet. All right, so let's see. I got a tiny rectangle, a little bigger rectangle. You guys know they're similar, perfect. I got 6 feet for the shorter side of the first one, 9 feet for the shorter side of the second one. The area of this one is 48 square feet. What's the area of that one? And I don't want you guys just finding the other side and then trying to figure out what this side is and multiplying. All right, I want to use what we just did here. First of all, similarity ratio between the two. Let's go. 17, similarity ratio between these two rectangles. 6/9. If you guys want to reduce it, feel free. Somebody tell me why this is going to be incorrect. 6/9, the similarity ratio. The area of the rectangle with the side of 6 is 48. Let's find the area of the side that's got a 9. Why is that incorrect? Totally incorrect. Totally incorrect. Frank? Hey, if you're saying this is correct, this is correct then. That the similarity and the area ratios are the same. We know that's not true. Frank, what do I have to do again? Square the similarity ratio before you get going. Please watch out when you're dealing with area. You got to square the sides first before you start cross multiplying. Yes. Did you find the other side? Okay, but here's the issue I have with that. What if it's a pentagon? And you can't do that. See what I mean? A rectangle, I get it. It's convenient. You just say, okay, this side's 8. Match them up. What's this side got to be? Multiply it by 9, and you got it. But again, what if I get another figure you're unfamiliar with? Okay. I just take the sides, square them, and set them equal to the areas. And the area of the bigger rectangle ended up being, here you go, 22, your time to shine, 108 square feet. Good job on the units. Questions, comments? Okay, you ready to help Benita out now? She needs a little help. Oh, perfect, Benita. Let's go. Let's go. Let's go. What do you want? God. Worst timing ever. I'll just start putting down the regulars. Star, Genie, curtains, pinwheels, shatter, star, oh, that's already up there, slide, fade, oh, can't forget the old page curl. Anything else before we vote? Clock, flip, all right, here we go. Stars. Any stars in the house? Stars? Nope. Any genies in the house? We got a genie. Another genie? Got two genies. Curtains in the house. Pinwheels. Shatters. 6. Slides. Fades. Curls. Clocks. Flips. All right, everyone ready for a little shatter? Shatter or the man? All right, shatter or the man. Everyone ready so we can get going? A lot of homework on the line. Shatter, Promethean man. Ooh, cube. Okay, cube. Matt getting a little heated over there, even though it wasn't even on the first 10, but okay. Here we go. There's another one there, spin out. All right, here we go. Get back to Benita in her field here. She's got 2 rectangular fields. Each with side lengths and a ratio of 2 to 3. Now, hold on. That 2 to 3 can get a little confusing. The rectangular fields are in a ratio of 2 to 3, not the corresponding sides. That's not your similarity ratio, 2 to 3. All right, that is not your similarity ratio. It's just the ratio of the sides in both rectangles is in 2 to 3. Each dimension of the larger field, 3.5 times the dimension of the smaller field. So if this one's going to be in a ratio of 2 to 3, 2 is going to become what if it's 3.5 times larger on the larger field here? 7. And what about the 3? 10.5, and I'm sorry, this doesn't look larger, but it is. It costs $8 to seed the smaller field. How much does it cost to seed the larger field? And a lot of you might just go, oh, 8 times 3.5, there it goes. Area is completely different. And by the way, how do I know this is an area problem? It doesn't say anything about area. How do you seed a field? Where do you seed the field? Inside. There's my seeds, by the way. Yep, I'm going to keep going. At least one more row. Oh, forgot 2 more. Okay, I need a little help here. What's the ratio? Somebody give me the ratio of 2 corresponding sides right now. 2 to 7. Right, 2 to 7, that's the ratio of 2 corresponding sides. How much does it cost to do the smaller field? $8, and I'm looking for how much it costs. Why is this ratio incorrect? I got to square what? The 2 and the 7, my similarity ratio, yep. And you'll start seeing it's a little bit more than just multiplying 8 by 3.5. It's going to cost a little more than that, I believe. And how much does it cost to seed the big field? $98. Okay, when you're working with area, you have to square the sides. All right, you have to square the corresponding sides. Questions? All right, let's go. Bring out your Regents packet. I'll go right to the bell here today. Let's get out the Regents packet. Maybe we can get one done, I think. 12, everybody, 12. Take a look at 12. Gives you two endpoints. What's the equation of the perpendicular bisector of them? And everyone take a look at the multiple choices. Anybody know what form they left that in? All the multiple choices. Anybody remember that form? That's point slope form right here. Yep. This is point slope form. Easily can be converted into slope intercept, y equals mx plus b. Okay. All right, so perpendicular bisector. If I'm going to take care of the perpendicular part, I got to find the what of ny. Slopes, here we go. Let's find the slope of ny. What goes on top, your x's or your y's? Y's, all right, so change in y's. -7 minus 5. Change in x's, 5 minus a -11, so 5 plus 11. So it looks like, let's see, -12 over 16. Anybody want to reduce that? Because it looks like all the answers. All right, we'll finish that one up tomorrow.